Ladies and lords of the loops, it's Prof G, and we've got more iterating goodness on tap. In the last lesson, you got the lowdown on loops using while and repeat while. In this lesson, we'll continue the spin for the win with an introduction to the for loop. And we'll learn how to implement for loops in 3 ways, using closed ranges, half-open ranges, and iterating through arrays. And we'll cover strides and the reversed method. Let's roll! So we're going to table the You Are Awesome app just for this lesson, and we'll work in the playground so we can have a brief but critically important lesson introducing the for loop. Now, even though we're not using for loops in the You Are Awesome app, you'll use these in other apps, and they're one of the most important concepts in programming. So since we've already covered while loops and repeat while loops, it makes sense to contrast these with the for loops now. So let's create a new playground. Why don't we name this for and for each loops? For each should be one word, lower camel case, lowercase f, capital E. Create this, adjust your window, and hide the left pane, and I'll delete the greening. Now in our last lesson we saw that the while and repeat while loops were great when you don't know how many times you want to go through a loop. Both loops terminate when a condition becomes false, but sometimes you want to go through a loop a specific number of times, and if that's the case, then the for loop is the loop to use. Let's take it for a test drive. We'll write a loop to count from 1 to 5, and to do that we say for count in 1 5, open and close curlies. Now this will execute the code in the curlies 5 times. 1 5 is a closed range, and you know those guys. We worked with closed ranges when we learned about random values. And count will be a constant we can use inside the curlies. Count is just the name of a constant. We could have called it anything, X or index or Nicolas Cage. But count is a good name for our counting example. And to print out the count, in between the curlies we just write print, and in between parens, count. Now the first time we go through the loop, count will be 1, the first value in our closed range. The second time, count will be 2, up through the 5th time when count is 5. And with each loop, the old value of count is thrown away, and we get the new value of count. Then, once we've iterated through the closed range, we've gone through the loop 5 times, then count goes away for good, and we continue on with our code. So to use one of our earlier terms, we'd say that count's scope is just between the curlies. Now also note, when we option click on count, we see that it's an int type because the range is given in ints, and we also see that it's a let constant. That means we can't change count inside the curlies. So now let's run the loop with shift return, and we get a count from 1 to 5. And we also see the results pane points out that we went through the loop, line 4, 5 times. Nice! Want to change the range? Let's change it from 0 through 10. That starts the loop at 0, goes through 11 times, ends at 10, shift return, and we see the number 0 through 10. Nice! So now let's see if you can apply your newfound knowledge of the for loop to complete the Tubbies challenge. So create an array named Tubbies with 4 values, Tinky Winky, Dipsy, Lala, and Po, and go through the array of Tubbies, printing each Tubby one at a time. Some hints. Can you create a range to go through all elements of the array? And can you use the value you iterate through to access a different element each time you go through the loop? Pause. Give it a shot. Resume. And let's compare answers. First, let's create a string array that contains the Tubbies. Var Tubbies equals, and in brackets the strings, Tinky Winky, Dipsy, Lala, and Po. And now for our loop. We start with 4, and then we can give the constant holding the current value in our range any name we want. Count, index, I'm going to call mine Tubby number. Follow this with the keyword in, then our range is 0 to 3 since we're 0 indexed, but just in case we've got another person joining the Tubbies, or in case a Tubby quits and decides to go solo, we can instead use Tubbies.count-1 to calculate the last value in our closed range. This way we don't have the literal in there, and the range will adjust to the size of our array. Then between curlies we just print Tubbies, which is the name of our array, bracket Tubby number, which will be that number 0 through 3 for our 4-element array. Make sure you got your close bracket and close parens, shift enter, and gather your rainbow friends for fun. We've got all the Tubbies in our console. Nice! So we've worked with closed ranges written like this: start value, 3 dots, and the end value. And these ranges include both the start value and end value and everything in between. Now in our code, I'll indicate that we're using a closed range here by changing Tubbies challenge to closed range. And I'll also comment out our first loop since I don't want to confuse the output with this other code. And now I'm going to show you a different range type, the half-open range. So I'm going to highlight and copy our Tubbies challenge code, and down below I'll write print half-open range, and I'll add a blank line before this print statement by saying print with an empty string inside. We learned about that in a previous lesson. And now I'll paste my copied closed range output under this, and to turn this into a half open range, we just swap out the triple dots with 2 dots and a less than symbol. Now this means go up to but never reach the last value in the half open range. Since we're never going to reach that last value, we want to make this tubbies.count instead of tubbies.count minus 1. So the closed range is 0, triple dots, tubbies.count minus 1. It starts at 0 and goes through tubbies.count minus 1. The half open range is 0, double dot, less than symbol, tubbies.count. It starts at 0 and goes up to but never reaches the last value, tubbies.count. So it actually stops at tubbies.count minus 1. So we'll shift enter down below, and our closed range and our half open range are identical. Now both of these do the exact same thing, but you're going to see both of these in your coding career, so know them both. I actually prefer the more explicit closed range, but there's a SwiftUI view creation technique named for each with a capital F and a capital E, but that SwiftUI view creation technique right now only uses half open ranges. So again, know them both, you're going to see them both. And here's a tip for printing. Now we used an empty string up here to add a line feed. Well, there's another technique. We can delete the line feed and instead just put a backslash lowercase n inside the double quotes wherever we want to add a line feed. So I've done that as the first character in my string here, so I no longer need to print the empty string. Now backslash n is called an escaped character, and there are a bunch of other escaped characters in Swift too. They all start with a backslash. Backslash r adds a carriage return. Backslash double quote lets you print a double quote in your print output. Backslash single quote does the same for single quotes. 2 backslashes will let you print a backslash. Backslash t prints a tab character, and backslash 0 prints something called a null character. And now here's another for loop technique. This is called iterating through an array. So I'll add a print statement, quote, backslash n, iterate through an array, and this technique lets us use a for loop to go through all of the values of an array, but we don't even have to write a range or use an array index. We just write it like this. For, then we give a name for the value that will hold each element in the array one by one as we go through the for loop. So I'll write tubby, singular, then the keyword in, just like before, but after this, instead of a range, I'm going to give the name of the array that we want to go through. So for us, that's just tubbies, followed by the open and close curlies. Now I could have used any name for this value tubby, but the programming convention you'll see most often is developers will use a plural for the name of the array, and then a singular to refer to the single element of an array. So let's option click on these values to make sure we know what we're looking at. Tubbies is a string array. See the brackets around string? We knew that, but if we option click on tubby, oh, it's a string, not an int like it was when we used a range. So this means that tubby is going to be a single element of the string array tubbies. Each time we go through the curlies, it'll be an individual string or element in that array until we've gone through all of the strings or array elements. Also note it's a constant with a let value, so it has a scope just like the index before. It only exists between the loop's curlies. So to be clear, each time we go through the loop, we get the next value of tubbies starting with the first element, we perform what's between the curlies, then we head on to the next element until we've gone through the entire array, and then we can continue on with our code. So between the curlies, let's print, in parens, tubby, then run this with a shift return, and look at that. Same output, but this time, without using index values or ranges, that's iterating through an array. Cool. And I bet you knew what was coming, Super Smart Swifter. It's challenge time. This is the quiz average challenge, so create an array named quizzes, and quizzes should contain the elements 72, 81, 89, 95, and 92. Then use a for loop to calculate the average of all of the elements in quizzes, and then print out the quizzes average when you're done. And if you want some hints, don't pause yet. Think about, how do you average? What is that basic elementary school math? What are you totaling up? What are you dividing? Check your work. Is your answer what you expected? And if not, why not? And bonus, use all 3 for loop methods, closed range, half open range, and iterating through an array. So now give this a shot. Pause. You can do it. And resume, and let's compare answers. So I'm going to first print out the phrase quiz average challenge, and underneath that, let's create that quizzes array, var quizzes equals, and in between square brackets, 72, 81, 89, 95, and 92. Then let's do the closed range option first, so I'll say print closed range option. Then we'll start this off with 4, then we need our increment value. I'm just going to call this quiz number in 0, quizzes.count minus 1, open and close curlies. Then it's just the basic math. How do you get the average? You total up all of your numbers, then you divide them by the number of numbers that you're averaging. So in here, why don't we get a total? We'll say total equals, and we want to continue to cumulatively add that total up. So we'll say total plus quizzes in brackets quiz number. But, oh yeah, Xcode tells us cannot find total in scope. We didn't define that box that's going to hold our total. So up above the for loop, why don't we create that variable with var total, and we'll set this equal to 0 since initially our total is equal to 0, but with every iteration, we're going to add our quiz to the total. And now I've deliberately got an error in here, and if you didn't have the error that I put in here deliberately, congratulations to you. But I'm going to put in some extra information so that we can reveal what's going on. I'll say print, and in parentheses, the string will be total equals string interp total, comma, quizzes.count equals string interp quizzes.count. And then average equals, and in between the string interp, I can perform my calculation right in here. It's totally okay. Total divided by quizzes.count. Now if we press shift return, and I get total equals 429, quizzes.count equals 5, and wait a minute, average equals 85, I can tell right away that those values aren't going to divide evenly. I should have a decimal value in here, but I don't see it. Let me hop over to Google Sheets. What should this value be if we average it right here? 85.8. That's not what I got. Oh yeah, I'm missing 0.8. Can you think what the problem might be? And while you're thinking, I'm going to add a backslash line feed character in front of the quiz average challenge. So it looks like we dropped our decimal, and if you thought that might have something to do with types, well, you're on the right track. Let's take a look at the different types that we've got. Option click on total, that's an int. Option click on quizzes.count, that's an int. And total divided by quizzes.count is an int divided by an int. That's going to give us an int. Now, if we divide two integers, but we come up with a decimal point, what does Swift do with the decimal point? It just throws it out. How can we fix this? Well, one way is we can type convert the two values in our calculation before we divide them by each other. So in front of total, I'm going to put the word double with a capital D. That's the type I want to convert it to. And then I'm going to surround total by parentheses, and I'm going to do the same with quizzes.count. So then we take the int value in total, we convert it to a double, and the int value in quizzes.count, convert it to a double. Double divided by double should give us a double, shift return, and sure enough, we get the correct value, 85.8. Nice! So with closed range done, now let's create an open range. I'm going to copy my closed range code. I'm going to paste it down below. Now, I don't want to put var in front of total because I've already created total, but I am going to reset it to 0, so I'll just delete var. Then in the print statement, I'll change closed to half open range option. I'll put a \n in front of this so that I get a line feed. Then, instead of 3 dots in my range, for a half open range, I do 2 dots and a less than symbol, but then I go up 2, but I never reach the value that's to the right of the less than symbol, so instead of going to quizzes.count -1, I'm just going to go to quizzes.count, because we'll never reach that, we'll stop at quizzes.count -1. Everything else is the same, shift-enter, we get the same result. 2 range options down. Let's copy this last code, paste it down below. Instead of being a half open range, this is going to be iterate through an array. And when iterating through an array, we don't put a range in our for loop. I'm going to replace this with just the name of the array, quizzes. Then I'm going to replace the name quiz number with a singular quiz. What's quiz? It's the element of the quiz array, which is just the individual quiz values. So I want to say total equals total plus and not quizzes in bracket quiz number. Instead, total equals total plus just quiz. Our print line remains exactly the same, shift return, we get the same result, and you've calculated an average by going through a for loop 3 ways. If you struggled with that, rewind and give it a shot again until you've really got the techniques down cold. But Swifter, we still have some more techniques with for loops. Now, one thing you might want to do is to perform a countdown. So I'll enter a print statement that just says countdown to distinguish this example, and you might be tempted to enter something like this. For countdown in 10.0. Open and close curlies will print countdown in between, and my version of Xcode is a little slow in catching the error, but when I try to go ahead and run this, it doesn't work. Now the error in the red ball isn't very intelligible, but if I scroll down and take a look in the console, I see an error that says fatal error, range requires lower bound to be less than or equal to the upper bound. Oh, our range has the first value, the lower bound, that's actually greater than the last value, which is the upper bound, so that's why we get an error. But we have a way around this. Let's use our original range, 0.10. Swift allows us to do that, then wrap the range in parentheses. And there is a method that we can apply both to ranges as well as to arrays that's called dot reversed. Notice how this is described in code completion. It returns an array containing the elements of the sequence in reversed order. Now we can apply this to a range as well as an array. It's not going to distort the original array or the range, but it's kind of like doing a type conversion. It takes the data out and then reverses it. So why don't we accept this by pressing return, shift return down below, and we get our countdown. You're ready to help Bezos, Musk, or NASA blast off. Nice. Now up next, I want to demonstrate stride, so I'm going to say print \n stride. And stride is useful if you want to count by, say, a certain number of values, like by 4s. Why don't we count the next few Summer Olympic years, 2024 through 2050? Well, we would say for year in stride. We see a bunch of options in code completion. I want you to focus on the two functions. We've got one that's a stride from to by, and another that says stride from through by. Highlight the one that says stride through by, and we see the description in code completion returns a sequence from a starting value toward and possibly including an end value stepping by the specified amount. So we start at the from value, we go through the through value, and we step forward by the amount after by, and if striding through that value happens to land on the value in through, then we show that value. If not, then we show the value before it that's divisible by the by amount. Now that's opposed to if we highlight the value that says 2 below. That goes up to the value to 2, but it never reaches 2. It's sort of like a half-open range. So the best way to understand this is with a few examples. First, why don't we select stride from through by? I think you'll use the option with through more often than you will the one with 2. And so for this Olympic example, from should be 2024, through should be 2050, and by should be 4. And in between the curlies, we'll print out year. Shift return, and we see the last value is 2048. Hey, I'm supposed to go through 2050. Why aren't I seeing 2050? Oh yeah, 2050 isn't divisible by 4. There are 2 left over in the remainder. So what we do is we show the last value that's perfectly divisible by 4, and that's 2048. Now to show you how this would work if we went through 2048, I can highlight the code we just wrote, copy it, comment it out with a command /, paste it below, and I'm going to change my through value to 2048. And when we shift return, sure enough, we see we end at 2048 still, but this is perfectly divisible by 4. That's why we stop there, and we see 2048. Now, just to show you what would happen with the 2 parameter in here, I'm going to once again highlight the last code that I wrote, copy it, comment it out with a command /, and I'll put a comment in here for notes that says stride 2 goes up to but not through the 2 value. Then paste the code down below, and I'm going to change through to 2, T-O. And then when we run this code with a shift return, we see we stop at 2044. How come? Well, that's because 2048 is what we go up to, but we never reach 2048. It's just like the half-open range, so that's why we stop at 2044. So now your notes have examples of using stride through and stride to. Now, what if you wanted to stride but backwards? Well, you actually can do that. Let's imagine, for example, if we wanted to print out the Summer Olympics from 2020, and we actually had the 2020 Olympics in 2021 because of COVID. That was the Tokyo Olympics. But for purposes of this, we'll say for year in stride, select the through option here, and we'll say from 2020 through, and why don't we see the Olympic years through 1982? And we're going to go down by -4. But it's totally okay to do that with stride. We'll open and close curlies, and we'll print out the year, and when we shift return, we see, oh, we end at 1984. How come? Well, 1984 is the last divisible year, so that's why we're not showing 82. That's a year with a remainder of 2. But we see it's totally possible to start at a from value that's higher than the through value and to go down by a negative value. Nice. Well, Swifter, of course, we've had more big learning, this time for loop style. We learned about for loops, we traveled through loops with closed ranges, half-open ranges, and we iterated through arrays. We learned about the reversed method. We learned to stride through and to values, and we used stride with negative values. You learned about escaped characters, and you met the throwdown of multiple challenges. Stride ahead, Swifter. Your skills are growing.